So next example is to count the lower and uppercase letter. The function could have two output. So number up, number lower like this. Okay. So this function is producing the two output that contain the numbers of the uppercase and the lowercase letter. Okay. We can use the similar syntax in the previous function, and then this one is the same with the previous one, and then to compute the numbers of the uppercase, numbers of lowercase, we can just simply summing up this logical vector, all the one in the logical vector. Okay, and then this code is returned this two output like this. Does it make sense? So here, this one is a command window. We can call the function in the command window as well. We define the character vector. If we put this character vector to here, and then we can get these two output like this. Okay. So we can design the function to perform this operation in a different way. What if we can make the second argument to let the user choose the lower or the uppercase? Do you remember sort function? We can sort the function. We can sort the vector in ascending or descending order. To do so, we need to provide ascend or descend the input argument, right? Similarly, we can make the second argument give such an option to the user. Okay, LT case is a letter case, the variable that we can put this option. Okay, how to evaluate the numbers of the lower or the uppercase depending on this option? We can use the if statement, and is equal, or this could be string compare. Okay, if LT case is equal to the offer, we only do this operation, and num character is the numbers of the uppercase letter. Okay, else if the letter case is the same with the lower, we are computing the numbers of the lowercase letter. Okay, do you understand this part? Okay. Okay. In addition, I also added this adder function, which is I briefly mentioned in the previous lecture, right? This is a very good example to use this function. But imagine that, so your friends use this, let's say it's a character vector, use this function like a upper, like this. So what do we do? How we design the function when the user put this kind of the wrong second argument? Offer, that one is correct, but what if we can put this wrong second argument? We need to produce the error message, right? Okay, so that is this function. Okay, what do you mean by else? If the letter case is not neither upper or the lower, that produces this error message like this. Can you understand this logic? We already learned all this syntax, right? We just do practice how to arrange them to perform our specific task here, right? Okay. So this is how we used this function. We define the character vector, capital character vector, and the second argument, and then this one computing the numbers of the lowercase letter. Okay, good. Okay, I'm going to talk about the concept of the local function. So in the previous example, I include only the one function in the M file, but we can include multiple function in the same file. The function of each name is the same with the file name. So like this one, that is the main function that should be placed at the first. Okay. And additional function are called the local function. Okay. For example, let's say my functions need to have two subfunctions, okay, to complete this operation. Okay. One way is to store this subfunction in the separate M file. Okay. So basically these are the 3 M file. Okay. However, if my functions sub 1 and my functions sub 2 are only used for computing the output of the my function here, and will not be reused for other purposes, storing this function at this file is much more reasonable, right? If you think about each function have, let's say, 10 sub-function. If you have to store this 10 function in the separate file, so your folder will be very messy and very complex, right? It's not easy to search for the right your function. So it is reasonable to store this function in your file that's stored in the main function. Is reasonable. That's much more manageable, right? So in that case, you can store the same 3 function in the same file like this. Then this become a main function, and these 2 are local function. Okay. The major difference of the main and local function is the only main functions can be accessed from the outside. Okay. Let's see this example. Okay. My one function store the my one function.m. These are the main function. And then there are 2 subfunctions. 2 subfunctions, these are the local function. That case, in the other function or script cannot call this subfunction. Okay? Because the subfunction can be callable inside of the my one function. My one main function called this 2 subfunction. My one subfunction 1 also called this subfunction, right? Okay, but other script function or other function or other script cannot call this subfunction. Okay, if you think that this local function could be reused for the other script or the function, you need to store this subfunction in the separate file to make this subfunction as a main function. Okay, does it make sense? These are the major difference between the main function and the local function. But there's a way to call the subfunction called the function handle, but you don't need to know at this time. Okay. Okay, so let's think about you're going to design the bulls and cow game. Okay, then you will only call the compute bulls and cow function, right? You might not call the individual compute bull, compute cow function, right? Okay. Then in this sense, the compute bull and compute cow, so become a local function, right? because this function in only the support operation inside of the compute pool and count, compute BC, right? Okay, so that's why in this case you can store this compute BC, compute bool, compute cow at the same file. Okay, then these are main function. That's why the file name should be compute BC. And then these are the local function. Okay. So you don't need to store this local function in each separate file. Okay. Compute BC called the compute bool and compute cow. Compute cow is a local function, can also call the another local function compute bool. Okay. Do you understand this logic? This is a very good example of the local function usage. Okay. Then the outside of this file, you can your script or command window, you can only call the compute BC. Then you will get the bulls and cow number. Okay, make sense? Okay. Okay. We can contain the function, there's some kind of script, a code to define the function in the script. Okay. I have a use of MATLAB for almost 10 years. When I learned MATLAB, this syntax was not available. Think about it, when you test your functions, you need to have a separate script file, so like my script. So let's see this example. This one. Yeah, this one. Okay. So you designed this compute bool. Okay. You want to debug this compute bool. You need this my script. Why? You need to provide this input value, a certain input, to see how to operate this compute bool, your function, right? This means you need to have this to file. Of course, you have this compute bool function file, as well as you need to have a script file to provide this input value. To debug this code, I should moving across this to and file back and forth, and then setting up the different input, and then this is corresponding the operation inside the function. However, since 2016, you can include the functions in the script. That's extremely convenient for testing purposes. Okay? Since the functions are as a part of the script, all these functions become a local function and cannot be accessed outside, but you can include this script and then you can test the function using the one script file. Okay? So let's see the example. This one. Okay, bulls and cow problem. So previous example, this script file should be stored in the separate file. But in this case, you can include this function in your script. Okay? But always your script plays in the beginning, okay, to use this syntax. Does it make sense? Okay, think about this one. Okay, here you have this script, you have this compute BC function, right? But to test this function, you need to have this command window, or you have this my script, right? But you don't need this separate file to test your function. That is very useful. Actually, you already used this syntax in the word puzzle problem. The given code, if you take a look at the word puzzle problem, the given code include the function to generate the word puzzle. But those functions is placed in the bottom of the your script part, right? So that word puzzle generates a function is the local function. That is only used for the generating the word puzzle inside of your script. The other file cannot access those function. Okay? Okay, does it make sense? Okay, good. Okay, variable scope is the workspace in which the variable are valid. So script use the base workspace. So all the value are stored in the base workspace. However, function does not use the base workspace, and every function has its own workspace. Function does not use the base space, its own workspace. Okay, base workspace and the function workspace are separate space. Okay, the variable placed in the one space cannot be accessed from the another space. That's the key part. Okay, the variable. Okay, I'll write down the variable placed in one space cannot be accessed from another space. Okay, so that's why the scope of the variable is limited in each workspace. As mentioned before, once we throw the input value to the function only accesses those value and cannot access any variable placed in the base workspace. Can you get this point? That's why we can use the different variable. Okay? No matter what variable defined in your function space, that does not affect the base workspace in your script. Okay? The function only provide output value, and then this output value is assigned to the variable that you define, that you place in the left-hand side the function statement in your script. Okay, does it make sense? Okay. In this sense, there's another benefit for using the function. Do you remember swapping operation? So let's say A 10, B 20. How to swap this variable? Okay. This is a very simple example. Temp A B A comma B B comma temp, right? You make this, this code, right? You should not code like this one, right? Because A is already overwritten by the B, so this one is wrong, right? But think about this example. Your purpose is the swapping the value, right? But if you write this script, you generate this unnecessary variable, temp variable, right? So this temporary variable is to remain in your base workspace, right? Okay. Again, this is a very simple example. But if we use the function, let's say, so let's assume that we have a swap val custom function like this. If you use this custom function, this temporary variable will not be stored in your base workspace, right? Because this is only the process inside of the function. The function only provided is a value that is assigned to the A and B, right? this all the variable used for the computing this swapping function or the other types of the operation is to disappear when this operation is finished in your function. Okay, that's why these are the using the function is memory efficient. Okay, we don't need to store this all this temporary, the variable. The variable is not necessary for the final outcome is automatically deleted if you use the function. Does it make sense? Think about this temporary function. Okay? For instance, it's a Boolean count. Okay? No matter what variable you used to compute the Boolean count, if you run this script in your workspace, you only have that's the 4 variable, right? That's the variable that we need. We don't need all this is same num_b, num_c, ii. We don't need such a the variable, right? But if you use this function, this variable is automatically deleted. Only this necessary variables remain in your workspace. Okay? Does it make sense? Okay. Okay, let's see this example. Okay. This is the exactly same code with this one. Okay. Okay. I put the breakpoint here. So red is a breakpoint. Do you know how to use the breakpoint? I used several times this breakpoint in the tutorial, right? Okay. When the script executes, where does the code stop first? That's the question. 10 seconds. Answer is 16. Not 6. Why? Let's see the one by one. First, then second, and define this x2 and xt. Then assign this input. We first run this compute BC. So we called this function compute BC. And then line 9 is called the compute bool. Okay. Actually, we skip this line 6, right? To call the BC. And then call the compute bool, right? This one is a direct you to this function. And then first stopping point is a 16. Okay. Does it make sense? Okay. So this is the first stopping point. If you see this, this one is I captured from the MATLAB. The workspace, there's a function name here, right? This means this workspace for the compute full function, not the base workspace. Base workspace is your my script workspace. This is not the my script workspace. That's why you have is the same and num_b and x2 and xt here. Okay. What is the next stopping point? Next stopping point is line 10, right? Once you finish the comp bool, the bool numbers of the bool is assigned the bools. And then stop 10, right? Before executing the compute count. So number 10 is the what is the workspace? Compute BC, right? Compute BC and then bools and then this two input like this. Okay. Next stopping point is the line 25. Because if you run it and then this compute count is executed and stop at the 25. And then here, this one is workspace for compute cow, right? And then run it, and then these are the variable generate from this compute call function. Then what is the next stopping point? Line 16 again, right? Because we called this compute balls here. Okay, so we stop the line 16. Okay, and then what is the next? Next is the line 11. Why? We finished the compute call process, then the numbers of the call is assigned, right? So compare with this one and this one. Okay, if your code is stop at the line 10, and then there's no call, right? Because we finished the process at the line 10, this call is created, right? Then, do you understand this process? How the variable scope and workspace are changing at each stop point? Finally, once we process of the compute BC, balls and counts are assigned to the BLS and CWS, like this. Okay? Does it make sense? Okay. Good. Okay, so before closing this lecture, so here's some simple example. Check what we learned in this model. Which code is executed without error? Okay. The why first one is an error? Because here, so we defined that these two variables. We call this a my function mean. And then in vector is assigned to this function. And this line, why this one error? You are accessing that is an element outside of this function. We cannot access the variable in the different workspace. We cannot access this an element that is placed in the base workspace, right? You cannot access this an element. That's why there is an error. What about this one? The only difference is this one. Okay? We don't need to match the output variable, but still this one is access the different an element that placed in the different workspace. That's why there's a still error. I mean, the point of this example is the error source is not this output variable name. You can use any variable name that follow the rule of making the variable name, the cover in the module 2. What about the third one? That is, you define the mf mean is the acceptor 2 input value, right? But in this case, you call this a function using one input, right? That's why there's an error. Okay? The final code is a working code. Since we cannot access an element unless we set it up the input argument, we need to recompute an element again inside of your function. Okay? Like this. Okay? That's it for today. So we'll do many practice on the defining and design the function in the rest of this course. Hopefully you can clearly understand why we use the function and how to define your function through this lecture. Okay, see you next lecture. Bye.